Hello. First of all, a big thank you to Quantic for hosting this. And it's a pleasure to be here, and it's going to be a very exciting session. We had a great discussion. And this is going to be important from a perspective of, if you think about the world we live in, we are going through a huge technology refresh cycle, and I'll talk about it later. And we'll try to summarize it in terms of what I mean, because we are living in an era where we are going to see seismic shifts in how software embedded in artificial intelligence is going to shape humanity socially, economically, and in terms of how technology is going to be democratized so anybody, any income group can have access to that. With that being said, let me start off with a couple of questions. Now, Mr. Bhalchandra, what role does edge computing play in enhancing embedded AI systems, and what are the benefits of moving this AI processing to the edge?
So good afternoon, everybody. I'll take this opportunity to introduce my company in just 1 minute. So I'm coming from KION Group. It's a German multinational company with a $12 billion revenue. We are world leader in supply chain and logistics solution. So we produce basically, forklifts or industrial trucks, also automated guided vehicles and AMRs, and we fully automate the warehouses. Okay. Coming back to your question, so I think the previous panel also talked a little bit about the benefits, like in terms of real-time data analysis, low latency, faster decision making, security and privacy in healthcare. So these are definitely the benefits. But I would like to draw the attention to how the moving AI on an edge can improve the operational safety in a warehouse industry. So as I mentioned, in warehouse industry, we use forklifts to move material from one place to another place. So for example, from shipping to packaging. These forklifts are very heavy machines. When they are moving the materials, the accidents happens for some reasons. And there is a very interesting statistics about these accidents in warehouse, published by OSHA, Occupational Safety Hazard Administration of USA. It says that, roughly 62,000 accidents take place yearly in warehouse due to forklifts in, operating there. And 35,000 of these accidents results in serious injuries or damages. And then 87 deaths happens annually, in a warehouse accidents because of the forklifts. So you can imagine one person dies every 4 days in a warehouse accidents due to forklifts. And 36% of these accidents happens, or the victims are basically persons or pedestrians who are moving on the floor, where the AGVs or forklifts are operating. And I'm talking about the data only from the USA. If you combine the data from the entire globe, then just multiply this number by 3 to 4 times, and you can imagine the issue of this safety, in warehouses. Okay? But the good thing is that the OSHA also says that 70% of these accidents can be prevented if you take certain measures, and that is where this AI on the edge comes into picture. So what we have done is we have put the smart cameras on the warehouse at multiple locations. So these cameras basically monitoring the locations and and the persons entering to these locations. So the moment the person enters into the location, the camera sends the signals to the AGVs or the forklifts, and when the forklifts is moving towards a person, it's automatically stops or slows down. So that's how it basically helps you to improve the operational safety, and it is all about the AI on the edge, because every decision is taken within a seconds. So that's how the AI really helps. Okay?
Thank you. And Karthik, I'm going to ask you to respond to the same question in terms of role of embedded AI in the edge.
Yeah, sure. So especially from the automotive context, right? So we have AI all over the place, right? So right from the infotainment recommendation to make a decision on whether to apply the brakes or not. So since the use case is so varied and wide, and there are 4 key parameters that we are looking for. Right? So the first one is the availability, right? So whether the AI would be available when you need it, right? So for most of the cloud use cases, it requires internet connection. So you may not always have the connection. For example, if you're in a subway or you're going for a basement, you lose the connection, right? So the availability is a key. And the second one is a latency. So as soon as you ask a question, you expect a response back. So not 5 seconds or 10 seconds back. So it directly affects how the user experiences. So, and the third point is the privacy. So with the Edge AI, we were able to localize a lot of the content, the user content on the device itself so that it does not leave the vehicle or the ECU. Right. So, and finally, there are regulatory concerns. So a vehicle can make only one external connection to the external world. Right. So it helps us to optimize the bandwidth with Edge AI applications on the vehicle.
Perfect. Okay, thank you for explaining that, Karthik. And Mr. Koustubh, what are your thoughts on the same question?
Yeah, so my thoughts are also in line with his thoughts, because when the systems are safety critical or time critical or both, say for example, systems like advanced emergency braking system or similar such systems related to ADAS and AD, there the time and safety both are at a criticality level, and we cannot depend on any remote connection to take a decision. So I always say that, of course, your AI/ML models can learn at cloud, but they must act at edge. There is no other option.
Yeah, thank you. That's a great point. Mr. Nikhil, from your experience, what do you think?
So I think the fellow panelists have covered most of the reasons why we need to go at the edge, whether it is privacy or the latency part of it. I'll not go more into that, but I'll directly tell you some use cases where we are actually working on edge. So when we, brief introduction about my organization that will help me to put the context of the things better. So I'm from Hindware, and we are into multiple line of businesses. Everybody knows us for our sanitary ware. We are still the market leader in that particular space. But other than sanitary ware, we are into appliances also. We are into pipes manufacturing. And one of the biggest business for us is the container glass manufacturing. So we are one of the India's largest container glass manufacturers. And in totality, we make around more than $1 billion turnover every year. Wow. And we have a listed company. So we ventured into the smart appliances. So, and to specifically focusing upon, we have two areas of interest, whether it is one is the smart bathroom and another is the smart kitchen. So anything that comes into these two spaces are area of interest. We started this journey of IoT and AI almost 5 years back now. So when we make our products were like Alexa and Google Home enabled, now that particular thing has got changed into a local voice. You know, now consumers are no more interested in going towards the Alexa because of all their privacy concerns. They want it to a local voice. It reduces the latency. It's like absolute instant. I say fan on, and I can make it very, very customized to my requirement. I say fan on, fan off, it gets on. I can tell in any language. Any command I can use. I need not to be, earlier when we made Alexa enabled, we fixed that you have to say this kind of statements to make the function one. I can set my own language. I can send my old command. I want to take a name of my daughter. The fan should switch on. I can do that. So that kind of flexibility we have got. Then that is one part, which is voice, where we have experienced this. Then second part is we have a vision, just like the connected cars. We want to make, or the self-driven car, we want to make all our products autonomous. You know, we want them to run with minimal or no involvement of human. You know, if you have a geyser at your home, you know, why at all you have to get up in the morning and go and switch on the geyser, and then after you are taking a bath, switch off the geyser. If I have to do that kind of things, you know, absolutely instantly, then it has to come on the edge. You know, we want to make a kitchen. We have recently launched a kitchen chimney which is like 100% autonomous chimney. You know, all the decision making, you know, what is that being cooked, when is the cooking started, you know, adjust the speed depending upon the cooking. So to make it really spontaneous, it has to be on the edge. The entire algorithm has to run on the edge. So that's what my take on this question.
Okay, perfect. I mean, thank you. That's the first round of question. I know we have 35 minutes left and we want to leave 10 minutes in summary for questions. I'll wrap this question with one important observation. What this is done is reduced dependency on the cloud, which means your cloud consumption and power consumption is going to dramatically reduce because of edge compute and edge inferencing. So this is going to be a bigger benefit overall, given the power infrastructure issues that we're having as data centers grow. With that, I'm going to go to the next question. How do machine learning frameworks and tools make AI more accessible for embedded systems developers? This is for Mr. Tanmoy.
Hello. When I will give my experience from the automotive background mostly, like where I'm working in the developing the solutions where edge computing is being used to detect the human behavior, those kind of driver monitoring system or ADAS kind of things. When we started, like if we talk about 5-6 years back, the framework, when that algorithm and models are being tested on the cloud using a data set, and to port it into the vehicle as a feature, it used to take almost more than 1 year. And to test it, then it used to go a lot of huge cycle to port that thing into the embedded system. Like we are developing things for the CUDA architecture. We need to port it from the to that embedded architecture, which is available for can be ARM-based architecture, it can be PowerVR architecture. So those used to take huge time. But in couple of years, like the new machine learning models framework came with their interportability architecture. Like for example, it came with ONNX. For example, somebody has developed model using TensorFlow, and another company, like as a tier one, we go to different companies and take their product and integrate it in our product. So somebody developed their model with TensorFlow, another person developed their model with PyTorch. Both are two different frameworks being developed by Google and Facebook. So it was, again, rework for us to convert it into our framework or edge computing which we are using. And we cannot give that setup to that vendor. So we have to do that in-house ourselves. We need to study, rework. But today there are open framework like ONNX framework are available, where we ask them that, okay, you developed it with the PyTorch, it is fine, but convert it into ONNX, give the model in that architecture. And the tool chain, earlier the tool chain used to very, very complicated, like we need almost 10 plus years experience person to handle those tool chain, to convert it to the machine learning model from the cloud to the edge computing. But today, it can be done with the DevOps architecture, it can be done with the, any fresher kind of guy also can do it. That is the simplicity also coming, the automation is also coming, the scripts are also getting, a lot of scripts are being added into those frameworks. I think this is and because of that, today we can take the model from any vendor, we can port it in our system within maybe 1 week, sometime it is 1 month, but the cycle, so that we can focus more on the testing side, because the testing on the product which will be deployed in the system, in the vehicle, in our vehicle, which we are going to buy, it needs a rigorous testing, and it has to run for, we want them to run for 15 years, 20 years. So we need to do the testing. So testing cycle has increased. So that is the major change I can see in the couple of years we are seeing.
No, absolutely. You know, when it started, like you pointed out, TensorFlow and PyTorch, they were a little complicated for anybody to use. And over time, it's now, TensorFlow has become so simple that anybody can, with some intelligence, build a neural network and start building applications. I mean, that said, at embedUR, we have launched something called modelnova.ai. Today, if you go to modelnova.ai, if you're a student or a professional developer, it's all free. There are 85 small models that you can use, download to a Raspberry Pi, and build your own image segmentation, facial ID, at really low cost. So I'll leave you folks with that thought and go to the next question. Mr. Bhalchandra, what do you see as the next frontier for embedded AI, and how will it impact industries over the next 5 to 10 years?
Okay. I think there are many innovations are happening in AI with respect to both software as well as hardware. Okay. But the notable one, what I think will be agentic AI or the autonomous AI. You know? That's going to have a massive role in the next few years. Okay? It is expected that agentic AI or autonomous AI will generate economic value of around $4.4 trillion, across multiple industry by 2030, so another 5 to 6 years. Okay? The question is, what is agentic AI? So how many of you know agentic AI, or how many of you have worked on agentic AI? Anyone? Excellent. So I see a few hands on. Okay. So I think many of you know traditional AI, right, or Gen AI, where you need to give the user inputs, or some manual interventions are required, and that AI system basically produce pre-programmed output. Okay. Whereas agentic AI or autonomous AI works very differently. It works independently. It's continuously scanning the environment, continuously learning from the environment, reinforces that learning, and make the decision. And most important thing is that they are working towards a common goal, almost independently without manual intervention or manual oversight. Okay, I'll give one example again from the warehouse industry, from where I come and where we are planning to implement this agentic AI. Okay, so if you see the warehouse objective, any warehouse objective, the goal is to always improve the operational efficiency, along with operational safety. The throughput of the warehouse has to be high, maximum. Okay, so how do you do that? So in earlier example, I talked about the AI system which was working on a smart camera, and detecting the person and then stopping the AGV, slowing it down. But when the AGV stop or slow down, you are actually impacting the efficiency of the warehouse or the throughput of the warehouse. Now this is where the agentic AI or autonomous AI comes into play. So you may have another AI agent sitting on another camera or smart camera who is observing the environment, who's scanning the environment. For example, it will know, okay, it is detecting which person is coming to a specific location, how much time is spending on that location, what time it goes back, and so it's detecting the pattern, and basically using that pattern, it can predict what time the person is coming and sending that information to another AI agent. That could be an agent which is basically planning the route for the AGV. So instead of now sending the AGV on a one particular route where it may encounter the person, and because of that it may impact your efficiency or throughput, it's find another route for the AGV to go, and where it will not encounter any person. Thereby also it achieves the operational safety because no accidents will happen. At the same time, operational efficiency is also improved. So that is how the agentic AI system will improve the operational efficiency and make the system fully autonomous without manual intervention. And when we say agentic AI, most of these AI agents are going to run on the embedded edge. So, and that is where you require a lot of power. So for example, you require networking, high performance networking capability beyond 5G. It may be 6G going forward, and even more computational power in terms of customized TPU or GPU or even VPU.
Thank you. That was great. Gaurav, I am going to start off with the next question for you. How is the convergence of AI and embedded systems transforming IoT devices and enabling completely new possibilities across multiple industries?
Sure. So thanks, Rajesh. Guys, just again to introduce myself, I come from Reliance Jio, and we are a big player in IoT space, and all the individual applications that were being talked about, Reliance has something or the other, and we are there, probably competitors for all of them. The convergence that we are talking about, so if you look at IoT started off with few sensors collecting data. So we started off with an mechanism where sensors were deployed that were only used to collect data. But of late, as IoT matures, as embedded AI comes into picture, you see a lot of different use cases coming in. Companies like Reliance have invested, and we have a lot of customers who are willing to invest a lot more into predictive problem solving. So now your sensors are becoming more and more intelligent. They can tell you when something is going wrong. There could be self-healing that comes into picture. That is something that is driving the industry now. So your entire industry 4.0, 5.0 is based on very much where you require predictive problem solving that has to happen. The other problem that, or the other thing that we are seeing, or a very big opportunity that today exists with AI being the edge AI or the AI coming to the embedded systems, is the workflow automation. So earlier you had certain IoT sensors, all the sensors were being monitored individually, they were not connected. Now you have end-to-end automation pipelines that are being there. There is a complete workflow that happens within an organization, and all thanks to the edge AI capabilities that are there. Because now your devices are not just used for collecting and sending data, right? And the other thing with AI being there is the security has increased a lot. So of late, if you have been following how the Indian government or all the governments across the world have been, they have been very, very strict when it comes to sharing of PII, which is your private information. So the more data that you can actually process at the edge, the better it is, because then you're not shipping that back to the cloud. So that security aspect also with all the governments across the world have now started pushing, and that's a very, very serious mandate that we get for most of our clients.
Plus, I mean, you guys are the master of data. You probably know what we talked about even before we talked about it.
Yeah, that's right.
Thank you, Gaurav. Okay, Nikhil, this is for you again. How do you think the convergence of AI and embedded systems is transforming especially IoT devices in your industry and enabling new possibilities?
I think I already told about the appliances and our area of interest. Now I'll tell you the direction in which we are working. So when you see the smart products, what we see today is just the tip of an iceberg, actually. The potential of IoT and AI and putting these six things together is like huge. So few areas which we are going to explore in going future. We have already achieved a remote sensing into our product. Our product are accessible from app, from voice, from geofencing, from anywhere in the world you can access the products. So that's one part of it. Second part comes the, which I told about the autonomous that make the products work by themselves. That is another area which we are going to explore with the help of AI as well as the embedded definitely is a part of, when we say IoT, the embedded actually becomes a part of it. Then the third area which we are going to achieve through AI is to achieve a zero breakdown in the field. None of our product should fail.
Reliability.
Prior to our product getting failed, we should have a system ready that should let us know that our chimney is going to fail in this particular area. Our filter of our water purifier is going to choke in another 15 days. So before the incident happen, we are able to repair it. That's another area. Then all our devices, we have developed our own IoT ecosystem. And we get the health data of our machine at a regular interval. So that's a tons of data for us now. And we are using that data to make our products more and more customized to the consumers, and the products of future are much and more reliable, and third part, then the next part is the sustainability. When we are able to control our product 100%, then we can also make it most optimized performance as well. That is also in our control. Whether if being a consumer, you want a powerful performance, we can give you a powerful performance. Being a consumer, if you want an optimized performance, best of the efficiency, we can do that. So that's there in our hand. We can run a fan and air conditioner in a simultaneous conditions, so that whether you want excess cooling in your room, whether you want energy efficient cooling in your room, so we can do that part also. So all these areas, which we are exploring our domain, and with definitely the AI and the IoT, definitely that's the edge part of it. Together will make these things workable for us.
Makes sense. Yeah, please go ahead, Gaurav.
Sorry, Rajesh, just to add to what Nikhil was saying, one very important thing, guys, is with AI coming to the edge or with your embedded systems, so we now see a lot of possibilities and a lot of new solutions that can be actually spinned off.
Absolutely.
Which was not traditionally thought of. With all the data that you were referring to being collected, we see a lot of newer problems which probably even the customer did not realize that he's facing. And there are possibilities of newer solutions that can be rolled out. So this emergence or this convergence that we're talking about is actually helping drive that. So it's giving us newer business possibilities in the market that people did not think a few years back.
No, absolutely. I'm going to go to the next question for you, Gaurav. What role do emerging technologies like edge compute, AI-specific hardware, and low-power AI accelerators play in advancing embedded AI systems?
Sure. So I usually handle the backend systems, and what we have seen is with edge coming into picture, right? If I give you a sort of a statistics, if you realize there are billions of people who use mobile phones across India, and your market for IoT devices or your market for embedded devices is probably 4 or 5 times it, because a person might carry just one single phone, probably 2 different connections. But today you might not even realize the number of sensors and the IoT devices that are being rolled out day in and day out. Now, all these devices, if they have to send back all the data, if all the data has to be processed at a centralized cloud, it's a nightmare. Your cloud cost, we have seen in certain systems, is over what your actual CapEx could have been. Even though it has to be an OpEx cost, your cloud cost is beating the cost that I might incur in setting up a proper data center and manage it. Because if you have a wrongly managed or a wrongly created application, it will create problems, huge problems for you. So that edge computing coming into picture has actually secured quite a lot of our data that comes in. It has actually helped us in terms of reducing the bandwidth requirement that is there, the processing requirement that is there. Everyone is aware GPUs cost like hell. So it is very difficult. And now our cloud is being used for better purposes because now the entire data that we receive,
Offload.
we invest in analytics. We have a big data lake, all the data comes in, and we have heavily invested in analytics that even our customers are actually looking at.
More value additions at the end of the day. Yeah. Karthik, your thoughts?
Yeah, so especially when it comes to the computing at the edge, right? So we are looking at multiple parameters. So the one is the performance per watt. So how much, A is nothing but mathematics, right? So how fast you can crunch your numbers, the better your responses and model would be. So on the one hand, we have the CPU-based processing, so and then GPU-based processing, and then we have NPU or AAPUs-based processing. So as we move towards the NPUs, so you get a better performance per watt, you can do more with less, but with less portability. So as you move towards the CPU-based processing, you get a better portability, but your performance per watt is not that much, right? So definitely the addition of NPUs and AAPUs to the today's embedded controllers will help us accelerate to a better performance per watt metric.
Perfect, thank you, Karthik. So I'm going to interlude, it's a small interlude here. So we talk about edge AI or AI in embedded systems. How many of you really understand or can articulate what that means? Anybody? We talk about edge and intelligence. So I'll give you a quick summary because this is very dear to my heart. Back in the day, there were CPUs. What is happening today is AI accelerators or neural processing units are getting embedded in devices, in low-cost devices, in microcontroller units. So microcontroller units, instead of having a CPU, as an NPU, neural processing unit. These NPUs are the ones that run the models and make the inferences that we're all talking about. And to use the NPU, you need to use tools to build models and download it into the neural processing units. Neural processing units complete an inference using one instruction compared to a generic CPU which uses 1,000 instructions. And it's very dedicated for neural processing. So it's not edge intelligence if it doesn't have an artificial intelligence accelerator or an AI accelerator in the chip, then it's not artificial intelligence. It's just doing normal compute and inferencing through a CPU. So I'm going to leave you my thoughts there in terms of what edge intelligence means. Because if you don't have that accelerator, none of what we're talking about matters, okay? So with that, I will go to the next question. Karthik, this is for you. How can security, privacy, and energy efficiency be maintained while integrating AI into embedded systems across industries?
True. Okay, so the security and energy efficiency, right? So those, again, so those parameters are considered in every deployment that we make. So when we say AI, so it has a lot of different flavors, right? So the first one could be your plain machine learning models, or the next level could be the small language models. So the next level could be the large language model. So not everything requires generative AI or LLMs. So we have to judiciously pick what we are going to apply on the edge. Right, so by balancing these with the long-term memory or short-term memory or the transient memory on the edge, we will be able to do a very efficient deployment of the AI on the edge. So for example, for most of the vehicular use cases, like you ask a question, it gives a recommendation, you don't need a LLM. So SLM will do the purpose and we can run it on the device. So, but if you have to depend on a 70 billion or more parameter models, so today's world, it's simply not possible to run on the edge. So we have to fall back to the cloud. So again, so if you are doing it on the edge, you have more control. We are only doing the inference on the edge, not the learning. So that gives you the enhanced sense of security and privacy for the edge use cases.
Yeah, and Karthik, as I was mentioning, see, since it's an edge device, it's a low-cost device or maybe a low-power device, it doesn't need as much compute because it's extremely efficient, so it conserves power over the long time. So that's why there's a lot more energy efficiency in the whole process, isn't it?
True, true. So yeah, so when we say embedded system, so it again runs a very gamut of the systems, right? So from the smallest microcontroller to a very powerful Qualcomm or NVIDIA based system. So both of them are called as embedded systems. So again, it depends on what is the problem or what is the use case that you are solving, and pick the tailored solution for that specific problem.
Yeah. So edge scales across smaller devices, mediocre devices, higher end devices,
So
right?
today's computer that we put in the vehicle are much more powerful than even my laptops.
Yeah. Thank you. Koustubh, your answer to the same question, security, privacy, and energy efficiency.
Yeah, so security is of course very well maintained when things are done at edge. Also the new act, DPDP Act, which is coming up, prohibits transmission of personal data, storing of personal data, and using of personal data without the consent of the driver or the owner of the system. And this consent has to be given by the owner, means it has to be handled at the edge by default. And this will cause some issues related to the training of the models, but this is inevitable, it's gonna happen. Secondly, as far as the power and the balance is concerned at the edge, I always think that whatever you could do through physics, you should do through physics. But then if there's certain things which are not possible to be done through physics, then you just use NNA, execute a deep learning model, and then get the inference out. For example, if you are doing, say, facial recognition, okay, so after you detect the face and the landmarking, beyond that, whether the driver is sleepy or not, can be two ways, either a deep learning model or a mathematical model. Better mathematical, because then the, the feature to power ratio at the edge is properly maintained.
Yeah, perfect. Thank you.
Rajesh, sorry.
Yeah, please go
In
ahead.
between. So guys, I think one important part of that question I think we all missed was the power efficiency. In the industry that we see, people really want devices that have a fixed lifespan, where you just plug them and you need not charge them that regularly, and that saves a lot of cost, a lot of money for them as well. The low power devices that you're talking about, low bandwidth devices, or devices that can be just deployed once and then replaced. So they have a big lifespan and they simply get replaced. So those kind of devices are in huge demand in the market. That is where the industry also wants us to actually move towards, because they cannot have devices being charged on a daily basis or a regular basis. So that too also is a very important point that we are moving towards.
Absolutely.
Rajesh,
And
I'll
that,
add-
yeah, please go ahead.
Just one example I share for this energy efficiency from our domain. You know, in our product, whether it is a kitchen chimney or a geyser, we have a tendency of everyone that after use they just put it to switch off. But and then when they will switch it on, when it is actually required. So that's a very human Indian behavior. So what we have to do, what our sensors cannot, you know, the moment your cooking is going on and customers switch on the chimney should know everything before that. So to make that actually happen, so we have to put a lot of power backup into the system. Here the energy efficiency is very, very important, because we cannot increase the size of the battery. You know, if consumer goes out for a vacation for a week or 10 days and then comes back, even my system has to run. So that consumption of energy for the algorithms, it's become very, very critical for us. We do that continuously, because most of the time we are assuming that, because that's a new normal Indian behavior, that we think if the product is power off, it's safe.
Yeah.
So that's the real use case why we are actually working a lot in this domain of energy efficiency.
Thank you. Thank you. That was a good, great insight. So I think we are running short on time. So I'm going to maybe finish up with, I'm going to combine the two questions into one. And so this is going to be the last question. So key innovations shaping AI and embedded systems, especially in automation and visual processing. Please, if Tanmoy, can you?
So let's take one part at a time, like vision processing. Like if we take the ADAS as example, like some OEM, they have developed their ADAS only based on camera. Some OEM, they have developed their ADAS based on sensor fusion, like they have integrated ultrasonic, they have integrated radar, they have integrated camera also. So gradually people are getting this point that if we are using camera everywhere in the terms of in the automotive case, for example, you are taking automotive case, the images, the requirement of the images are also growing up. Like for example, we started with 1 megapixel or below 1 megapixel camera. Now OEM is asking to put us 5 megapixel camera. The processing power also required very high. So that is one challenge we are getting as a tier one, for example, that every day we need to increase the power of the camera, resolution of the camera, so that processing power also needed to be improved. Because of that, lot of other chip manufacturing companies, they also started bringing up their chip. For example, they are dedicatedly making the chip for automotive use cases only. For example, Umbrella, I can take, Geosemi. So they are the chip manufacturer. Using them, we are developing this kind of application. So they are also taking up this challenge that, okay, we will bring up our new chip with the, like the mobile phone we see, the nanometer size is going down. So that is also happening in the automotive and other edge computing cases also. Also another thing is happening, like I think Mr. Karthik will also agree, the car architecture is changing completely. Like the more automation we are adding electronics. And we are adding the computational power, we are adding the chances of failure, and that is the biggest fear of an OEM, that when they will get the recall campaign, right? To avoid that, so they are trying to consolidate everything into one architecture, one PCU, one CPU, one domain controller unit. Recently, Mahindra got their new vehicle with their zonal controller architecture. It is a complete game changing in the automotive industry. So these kind of changes are happening. People have started consolidating their ECUs. Like I have seen recently in the CES that people have camera and radar. They developed a new camera module which has integrated the camera and radar together. And they're doing the ADAS focusing on top of it. And it is doing better than if we are using only camera or only radar. So these kind of changes are happening day-to-day basis.
Perfect. Thank you so much for that. And again, visual processing, image segmentation, facial ID recognition, these were all considered a really expensive proposition 5 years ago. It's going to become cheaper. It's going to become so prevalent that posture detection, all that can happen in very low-cost chipsets. So we're going to wrap here with questions. And now I'm going to go ahead and engage the audience, because this is the time. I'm sure a lot of you are hungry. So we're going to really find out if you understood what we were talking about. So there is a card. You raised your hand, right? So there is a card in your table. Can you tell me what the card says?
Yeah, the card says, what are your thoughts on edge computing significance into India's growing AI landscape?
So you can either answer the question or based on what you understood from us, or you can ask us a question.
Okay, I'll ask one question. Maybe it is related somewhat to that itself. So, there are different hardware accelerators. You can have GPU, NPU, TPU, all that stuff. So, this is a question to all of you guys that, given a chance, which hardware accelerator would you like to bet on, or rather, which one would you think will win? That is, which one would get adopted, much more faster? So will it be a GPU, NPU, and so on and so forth?
I have my opinion on that. So, but is there anybody who wants to take that question?
Yeah, it all really depends on the application that you wanted to build, right?
Exactly.
So for example, it is image processing application, so definitely the choice will be mostly GPU, So in our case, for example, we use NVIDIA Jetson board, which has more processing power for, processing images, That's where you will go, That's my answer.
Thank you.
And exactly, it depends on the type of applications, right? Now, if you think about IN, I will think about it in three ways. IN, middle-end, low-end applications, okay? IN, you have to go with something like an NVIDIA GPU, okay? Middle-end, you can probably choose something like an AMD, and you can get away with it. Low-end, if I have to make a bet, I'll make a bet on ARM Cortex and ARM accelerators, because ARM supplies to 120 silicon companies, and it's their de facto ARM accelerator chip. So if you're building low-cost, low-end, highly volume-specific products, I would go with anything that has an ARM accelerator NPU in it, right?
Yeah, thank you. One more question on this.
If we'll give us, please hold on. Is there anybody else? Yeah, yes, sir, please.
Okay, so the card says, what did you understand from the discussion on improving AI's accessibility to embedded system developers? Very interesting, very pertinent. However, this gets to the another question. How comfortable are leaders in embedded system ready to share their knowledge and maybe part of their infrastructure for getting a mass into this topic? Example, the traditional IT which is there, we have got so much open source things available. Even college students are now capable of developing things and innovating things. In this case, for the panel, let us say if Nikhil is ready to share Hindware's things on a Geo Cloud or a Google Cloud, it will be easy for us to access this and develop and give innovative solutions. So maybe is this what I have understood out of it? Assessing the AI within a company or a firm, making it more accessible is okay. But are we really getting the hardware, the components abstracted and giving to the community as a large? Yes, of course, having the safety and the proprietorship taken care of. So this is one question. And secondly, coming on to the thing is the cyber security angle or the safety angle for the enablers. So these are my thoughts on this question.
And can you repeat that question on the card?
Yeah, the question is, what did you understand from the discussion on improving AI's accessibility to the embedded system developers?
Okay, thank
so
you.
If I am a system developer and I want to develop, I don't have the access to the pain points which you people are bringing out.
Sure.
Okay.
So,
I'll let-
Rajesh.
So I think partially you have answered your own question. The main concern here is the data security and data, both privacy as well as protection. Now, we always request to the government that give us some kind of a framework in which we can work upon the data privacy. For the smart products, one of the challenge which we are facing today is consumer think, I don't know what kind of data you will take from me when you put your IoT in a kitchen chimney, whether you put it in a water heater or even a toilet seat. That's the biggest hindrance in the adoption of, because we are a consumer facing organization. So people are really, really concerned about, what kind of data we are capturing because we are everywhere inside your home. So sharing of that kind of data and framework, we can only do if we have some kind of clear guidelines. Under these guidelines, you are actually allowed to do it. So with this data protection and privacy bill coming in and then getting, I think we will get some kind of, direction. Then only we will be able to do it. Otherwise, it's like a complete closed box.
Yeah.
No, but Nikhil, my view is a bit different because I see Indian government working quite a lot there. There are calls that you need to tell the end customer what data you have collected for him. He should have visibility on that data, and if he selects, say later down the road, I onboarded a customer, 6 months, 1 year down the road, he wants to just get all his data deleted. I also need to provide that option. Now, it's very good in principle. Practically, we are facing a lot of challenges. That is where all the telcos and all the different companies are working. But in terms of security, trust me, IoT still somewhere falls into the telecom domain. The security guidelines are quite strict when it comes to how you are actually managing the devices, which endpoints. Most of your IoT devices, if they have to send something back to a particular cloud, that will be IP-based whitelisted. It is not that they'll just send something to world at large or over the open internet. So that is security aspect. Yes, it's one of the important parts that we take into consideration, and your data is quite secure. The other part that I wanted to come to you, and if you have been following news and you would have seen Mr. Mukesh Ambani also announcing, many companies today want to open up their infrastructure for people to start exploring on the different AI use cases that are there. Of course, having said that, there is an IP part that we want to protect that will not be open because that is our bread and butter. But when it comes to infrastructure, you would have seen the announcement of the the Geo AI cloud coming into picture, right? So that is where the industry is moving. People want more and more people to get onto it, try to sort of explore with different modules that are there, so that you guys also help us build an ecosystem that we can actually further build upon, right?
No, so my take on this is, listen, There is private data sets, there are public data sets. Private data sets, I run a company for the last 40 years. I've collected all my private data from my customers. I've built a model, I'm monetizing it. So there's no point in open sourcing that model. Now, there are public data sets, and there are a huge number of startups that are involved in synthetic data AI. Whereas, where you can go and say, I want to build an image recognition model to recognize my pets in the house, then you can create synthetic data immediately, and you have frameworks where, example, like I told you, we have an open source model zoo that we have created, modelnova.ai, where there are 72 different models. Today, you can take one of those models and actually apply maybe this image recognition based on what image you want to recognize. Let's say it's all sorts of dogs. You have an image recognition model in our website. You can go back and retrain it to dogs and then actually build an application that you can use to go detect the pets in your house. You see what I'm saying? So it's kind of, the data sets are primarily driven by your application and what you want to do. And some of the corporates are using their own private data sets that they've collected over so many years to perfect their model of implementation, right? Because at the end of the day, your AI or your model or your efficiencies are only as good as your data. And today, even how much ever you try, your model accuracy still only sits at 97%. You cannot achieve 99% model accuracy. So, there are data sets available. There are lots of public data sets available. It depends on what you want to do and how you want to use it to make AI accessible for yourself, for your family, and for everybody here. Okay, so I think time's up, but should we give him one last question? Or?
Yeah, sure.
Last one.
Question.
This is the last one.
Yeah, thank you so much. So one last question is, again, related to hardware. Do you guys see that, instead of using GPUs, NPUs, hardware is more moving towards, ASICs? That, let's say, if I want to have a very good facial recognition model, which has been already built into that ASIC, right? And then instead of using a generic NPU or a GPU, we just use that chip instead to do all face recognition and all that stuff. Would you see this happening in the future?
Can I answer that?
Yeah.
Yes, sir, because if we make those ASIC, for example, I worked with the ASIC, what you were talking about, and it is a part of many people's laptop today. And people are appreciating because the size of this chip is very small, which is there. The power requirement is there. It can do only one task. It will not capture any, for example, if it is talking face recognition, it will not send the face image to anywhere. It will process and give the signal, either yes or no, or the person is right or wrong. So people are appreciating that whenever some specific use cases are required, very specific, like for example, monitoring, some people are using that similar system to monitor the people and, for example, lock the computer automatically when people are turning off their face. So that kind of specific application, when it is required, people are appreciating because it is a very low cost. Implementation is very also interesting, but it can be fit into a very small form factor. So those things are, people are appreciating.
Yeah, I mean, what he said is right, but ASICs ASICs are counterproductive when it comes to software-defined vehicles, because the idea there is continuously keep on upgrading your functionality, features, basis the latest advancements, give new features. Your ASIC is a closed-door compartment. So it has neither upward compatibility nor downward compatibility. You can upgrade the model inside the ASIC probably, but you cannot add another model inside the ASIC, and that is a big problem. So going into the ASIC way is like going back in time.
Yeah, I totally agree, right? ASIC is very cost prohibitive, very expensive. Designing one and then fabricating it and then selling it at scale is a huge, huge task. So if you want to run a profitable business, profitable application, based on what kind of application and target market it is, you can license ARM core accelerators. There are already predefined ASICs available in the market, and I would just go choose from one. I just told you, ARM is licensing it to 100 ASIC vendors just in the US. If you take this across the world, there are close to 10,000 ASIC vendors who are doing fabulous semiconductor design. So there are dime a dozen over there that you can pick, and I wouldn't build, I would go buy.
Thank you so much.